All right, so it says we're recording, so I'm gonna get us started here. All right, y'all, so 6.8. Oh, one's coming in. Let me get one in real quick. There it is. There it is. All right, y'all, so this deals with increasing, decreasing, and piecewise functions. So we're going to start out with piecewise functions. So y'all, the best way to describe a piecewise function, any of y'all work a job that's paid by the hour?
Yes.
Now, do you get the chance to work, say, overtime?
Yes.
No.
All right. So if you work, say, 30 hours and you work 45 hours, do you use the same formula to figure out the pay?
I think so. Yes, I believe so.
Well, so
Yeah.
usually when you work up to 40 hours, you'll get so much dollars an hour. But if you work overtime, usually you get time and a half for that, right?
Yes.
Mm-hmm. So this is what a piecewise function is. We look at the values of our x's to determine which function we use to evaluate it. Sort of like I was saying, if you work 30 hours, you might get, say, $20 an hour. So you're going to get 20 times ever how many hours you work. But once you work, say, 45 hours, you'll get your 40 hours at regular pay, and then you'll get the other 5 hours at time and a half. So that's what we mean by piecewise function. There's different pieces of it that determine your outputs. So a piecewise function is a set of functions that uses the value of the x to determine which equation we use. To determine the function. Or how about to determine the function value? So we're going to play with one of these. All right, so my piecewise function will be f of x equals, and y'all, I'm going to have 3 equations here. It's going to equal x squared for any x's that are less than -5. We're going to use 3x for -5 being less than or equal to the x less than 3. So that means for this function, if it's -5, but still less than 3, say 2, then I would use this middle equation. And then it equals x minus 4 for any x that is greater than or equal to +3. So y'all, for any x values that I get that are less than -5, I would plug that x value into the x squared equation and see what I get. If it's -5 all the way up to say 2 or even 2.99, I would use the second equation, plug that value in for the x and multiply by 3. If my x value equals 3 or is greater than 3, I'll plug that value in for the x and subtract 4. So the first thing we want to know, which equation would we use to find f of a -15. So I don't want the value you'll get. I just want to know which equation you would use to find f of -15.
X squared.
X minus 4.
Oh, I think
X.
I heard two different things there.
X squared.
X squared, because if you look at the x values, that -15 is less than -5, right? So that means we would use the x. Now, if that had been a +15, then I would have used that last one y'all were saying, okay? All right, so let me do another one of these. Which equation would we use to find f of a -5? All right, y'all, so my x value is now -5. So first, second, or third equation?
The 3x equation.
The 3x, there you go. Because that one actually had that equals toward that -5, right? So since the -5 could be less than or equal, we had to use that one. All right, so now I'm going to hit y'all with some different things they'll ask you. Find each value. So y'all, first thing I want y'all to find me is f of the -6. So which equation would you use and what value would y'all get?
X squared. 36.
So good job. You'd use the x squared one, and that would definitely be 36. All right. F of -5. And y'all already told me which equation y'all would use for that, right? The 3x.
-125.
All right, so let me see. Are you okay? So you're putting in the -5 for the x, so you got 3
That
times
would be -15.
-15. There you go. I think you was cubing it. All right. F of how about 3? What y'all think on that one?
X minus 4 equation.
So that'll be what, a 3 minus 4?
-1.
-1. There you go. So that's what kind of stuff they're going to hit you with on the piecewise functions. The very first 3 problems or so, they just want to know which equation you would use to figure out your value. And then toward the end of the homework, they start asking you to find each value. So I'll actually do some more of those toward the end when they start asking us for the values, okay? So what I want to do, we're going to go back and we're going to play with the increasing and decreasing, which we did the other day. So I'm going to share my screen to the homework page. All right, y'all, so here we are the other day. We was playing with these. So I'm going to make this a little larger. So my first question, the function is increasing on what interval?
C.
What'd y'all just say?
C.
Oh, you're so close, but remember, you don't want that bracket. You want that to be,
Oh, the A.
yeah, use the parentheses. And y'all remember what she did? She's looking at the X values. And if you go across that X axis where this equation starts going uphill on the right side, it starts at 3 and heads towards infinity. So you'll click that. So how about what intervals is this function constant? So let's see, that's where it's going straight across. So I'm looking on the left side where it first starts going straight across.
B.
So the -3 to 3.
B.
B, there you go. Now y'all be careful, they put them brackets on those, but these points can't be going downhill and constant at the same time. So that's why we got to use those curvy bracket parentheses, okay? All right, y'all, then you would go on, and I bet it's going to ask us for the decreasing. So the X's are coming in from the left. It looks like the first part of this graph is decreasing until I hit what X's. So what would y'all pick?
Is it C?
Let me
Yeah,
see.
C.
C, there you go. Negative infinity to -3. All right, now, y'all, pretty soon they're going to have a tricky one on us. So let me see. I want to go to this question number 6. All right, y'all, let me make this one larger.
Yeah, I had this one and I struggled with it like really hard.
Yeah, it's sort of different. So the first thing they want to know where it's increasing. So that means from left to right, my graph is going to go uphill. And I'm noticing 2 parts where it sort of looks like it's going uphill. I noticed the first little upside down U, that left side sort of going uphill. And then after you hit that first little constant streak there, it starts going uphill. So I'm going to play with that left side first. So I'm going to get my parentheses ready. Whoops. So the left side's going uphill at the beginning of the graph. And that arrow means it's coming in from the left from a negative infinity. And then we got a comma. So now we got to figure out that X value where that graph stops going uphill and it starts going downhill.
-7.
So -7. So what you do, you're going to close those parentheses and put a comma and open up the parentheses for the next one. All right, so this, what y'all just say?
-2.
-2. And it's a pretty short one there, right?
-1.
To -1, there you go. All right, so we would put in them 2 intervals. Now here, you just use a comma to separate these 2 intervals. And let's see, we'll check that answer. So now decreasing, and y'all, I only see one area where this graph is going downhill from left to right. So I'll let y'all figure that out while I sign one in real quick.
Starts at -7 and stops at -5.
So let's see. Oh, good job. It definitely starts at -7 and stops at -5. So we'll put that in. And y'all, that was the only place there. So we're going to check that answer. So now I bet they're going to hit us with the constant. So y'all got 2 places where this is constant.
Starting at -5 and ending at -2.
Ooh, good job.
And then another parentheses opening at -1 to infinity, positive infinity.
Ooh, good job. You're on the road tonight, ain't you? There we go. And y'all, that's the trick of these, is just playing with these, each one of them, and never giving me the Y values. They don't care what the Y values are, anything like that. They just want to know the X values, where it goes up, down, or straight across, okay? All right, so before we do the next problem here, I'm going to go back to my page and let you know what we're talking about. On the relative minimum and relative maximums. All right, so y'all notice sometimes when you have a graph, those parabolas we was doing the other day with the vertex formula, they had a minimum or max. But y'all, sometimes the graph will go uphill, will turn downhill, and then go back uphill. So a new word for us is what we're going to call a relative maximum. And then we'll look at a relative minimum. So a relative maximum, they're not talking about for the whole problem. They're just talking about these little sections where you get these humps. This would be a relative maximum because it's relative to this little section of the graph. So when I look at relative maximums, I'm looking for any peaks that occur in the graph. So when I'm looking at a relative maximum, I usually look at so we want the X value where the maximum occurs. And the amount. So say this had an X value of 4 and a Y value of 5. I would say this has a relative maximum at X equaled that 4 and had a value of the 5. And then guess what? The relative minimums are going to be like little valleys in the graph. So that'll be any peaks that occur in the graph. And the same thing, we want the X value where the minimum occurs and the amount. Okay, so like this little graph I had, it had a minimum and a maximum, okay? Now, this thing's headed off towards infinity eventually, so it's not going to be the maximum for the whole graph, but it will be the maximum for that section, and then the minimum will be the minimum for that little section of it. That's why they call it a relative max or min, okay? So now these problems I'm going to show us on MathLab, they'll ask us for any relative max or mins and intervals where it's increasing and decreasing. So I'm going to give y'all a second to write that and then we'll move on. All right, y'all, so let's go back to the MathLab. All right, so let me make our graph bigger. So y'all notice their first question. Does this function have a relative max or minimum?
Max.
Max.
All right, so you'll click your max, and then it's only going to give you one chance on that, I guess. So now they want to know the relative maximum occurs at x equals what and has a value of what?
Is it x equals 6.5 and
Uh-huh.
then has a value of 2.25?
There you go. So watch out, because a lot of people put them backwards, and it's definitely going to get you if you go backwards, okay? So they'll ask you for the x equals, it wants that first coordinate, good job, and then the y value is that value. Sort of like on the vertex, right? The y values were the min or max values, right?
Yes.
All right, so what intervals is this function increasing?
Negative infinity to a negative 6.5.
Perfect. So since that is basically the vertex of this graph they're giving us, that x value is the point where it switches. So good job. You're doing pretty good on them intervals tonight. And how about decreasing?
Negative 6.5 to infinity. So B.
So there you go, B. All right, y'all, then you will check that answer and move on. So let's do a big one here. Let me get this thing zoomed in. And y'all, if you notice, I got a little bit of everything on this one. So the first question, the relative maximum is blank at x equals blank. Notice they reversed the order. Before they wanted the x value first and then the max or min. So be careful on this one because they're sort of reversed in the order. So y'all see my maximum. So what are y'all putting in here?
So would it be -1 and -6?
There you go. So that's what y'all got to watch for in this section. They try to trick you up by putting them out of order, okay? All right, so I bet they're going to hit us with a minimum now. So what are you putting there?
-33 and 2.
So negative 33 and 2. All right, then it wants me to continue. It's probably going to hit us with this one, increasing. What are y'all putting on increasing?
Negative infinity to -6
Uh-huh.
and 2 negative or +2 to infinity.
Oh, y'all are rolling. Good job. So that'd be, looks like B, right?
Yes.
Y'all, this section ain't bad when y'all are answering like that, okay? All right, I bet it's going to ask us for that other downhill. So where is this function decreasing?
Would it be
-6 to +2?
Yeah, that's C. I think someone said a C. There you go. Perfect. And then you take that answer and you move on, okay? All right, let me make this one larger. Now this one, you sort of got to read the problems over here, but it looks like we do have a relative max and a relative minimum. So we got to rule A out. It says there's no minimum, but we do have one. And then B, we got to rule out because it says there's no max. So we got to choose between C and D. Is the maximum -3 at x equals 2? Or is that maximum 1 at x equals 0?
D. So
D.
Mm-hmm. And since we know that part's right, let's see what else it said. The relative minimum, -3, happened at the 2. So usually there's only one right answer for the start of this. Once you get it, the second one's got to be true. All right, so let's see. That's what they want on this. Oh, y'all, that was it on that. And so they're not too bad toward the end. So y'all, let's do a couple piecewise functions real quick. So we're on the last two for this section. So who wants to figure out what g of -3 is?
I could probably do it, Destiny. I'll give it a try.
Okay.
I just have to get it written down real quick.
Oh, that's good. I'm going to try to write that down too. So if I got to go through my paperwork here. So we got what? G of x equals, our system of equations is x plus 5 for x less than or equal to 3. And then it's going to be 7 minus x for any x's that are greater than 3. So let's see, they want us to find g of -3, g of 3, and a g of 7. So y'all let me know when y'all got that, and I'm going to switch it to our pad to work these out. Anybody still writing? All righty.
Yes, just a second.
All right, y'all. So find me g of -3.
Oh, my bad.
So first of all, I'd sort of like to know, are you going to use the top equation or the bottom?
I think the top.
Okay, that sounds good. So you're going to put a -3 in for that x. And add 5, which gives us
Q.
all right. Next, y'all got g of 3. Which equation and what are you going to get?
The bottom equation and 4, I believe.
All right, see, I just got you. Because see what that bottom equation said? It said for any x is greater than 3.
My bad. It's the top one.
Because that one says the x can be less than or equal to 3. So you're going to have to put that 3 in that top one, okay?
Okay.
So y'all watch out, because guess what? They're going to, these little 3s on this one was the changeover point, and they're going to try to hit y'all with those on almost every problem we do. All right, y'all, and if we add that, looks like we get what, +8. All right, how about, I'm going to let you redeem yourself on a g of 7.
Use the top one,
Which one are y'all using?
the top equation.
Okay, so remember, to use that top one, your x has to be less.
Oh, sorry, yeah,
So we're going to go with the
second.
second one. So you would do 7 minus 7, and I guess that gives me a big O 0. So let's go put these in, and I'm going to let I'm going to give y'all a tougher one to redeem yourself with, okay? All right, so we said g of -3 was 2, so we'll put in our 2 and check that. We said g of 3 was 8. And y'all, I think that's the trickiest thing on these problems, is just figuring out which equation to use for these numbers, because they're going to try to trick you up on them. And then we said this one was what, a 0? And check. All right, y'all. So let's write this next one down and we'll figure it out. Now look at this. This thing has three equations. We got h of x equals negative 2x minus 15 for any x that's less than negative 4. Now remember, that don't include negative 4. They got to be less than negative 4. The second equation says it equals 4 for negative 4 less than or equal to my x less than positive 4. And then it's going to equal x plus 2 for any x's that are greater than or equal to that 4. So notice what they want me to find. They want me to find h of a negative 10, h of, what's that, a negative 2, h of a positive 4, and h of a positive 7. All right, so I'm gonna let y'all write that down and then we'll switch to the pad. All right, y'all, so here we go. So y'all, your first one is h of negative 10. Which equation would you use?
I might be wrong, but would you use the last one?
So let me see. Oh, well, the x plus 2 you can only use if it's greater than or equal to a 4.
My bad. I didn't see the negative in front of the 10. I'm sorry.
Okay. So you got a negative 10, which means we're going to revert up to the
Top one. I'm
top
sorry.
one. So that's negative 2 times negative 10, and then minus our 15. So let's see, negative 2 times negative 10 is 20. 20 minus 15 gives me a 5. All right, y'all, what did they have next? H of negative 2. I get people on this one also a lot. So for h of negative 2, would you use the top, middle, or bottom equation?
The
The
middle.
middle.
Oh, good job, because negative 2 is definitely in between these two numbers. So if you use the middle equation, it tells me that the answer is automatically
4.
4. Good job. So that's almost like one of them little constant sections of the graph. So that's telling me that this would be constant in between that negative 4 and 4 because it's only got that one answer of 4, okay? So let's see, x was, okay,
The last equation.
h of 4, definitely, because it's equal.
4.
So that'd be what, a 4 plus 2 would give us a 6. And then I had an h of 7.
Also the bottom equation.
So that'd be what, 7 plus 2. And that'll give us a 9. So y'all guess what? That is all of 6.8. So let me find some notes real quick. I'm going to play with y'all. Just get you a heads up of what's coming up. Oh, here it is. So y'all, let me ask y'all this. Are any of y'all going to be taking like business calculus in the future? Okay. Well, guess what? You
Yes.
get to learn this thing anyway, okay? So this is just a preview of 5.4 that we got coming up on Monday night. I did have this due this week, but I didn't want to get too much material for y'all in 1 week. So we'll just look a little bit at it tonight, and then we're going to knock this out Monday night. And then I might be able to start reviewing for that second test that night also. But we're going to look in this section at what we call the difference quotient. And this is another way to find the slope when lines are curvy. And it's really similar to that slope formula y'all know. So the difference quotient is f of x plus h minus f of x all over h. So h, the top part, f of x plus h, this is like y2 minus f of x, which is like y1. So that's the y2 minus y1 stuff. And h is just the difference between the x2 minus 1. So y'all might remember that slope formula for a straight line. So this is how we do it on a curved line. So I'm going to run one example for you. F of x equals 7x minus 3. They want to construct and simplify the difference quotient. Now, they'll give you this formula. You don't ever have to memorize this. So they're giving me f of x is this right here, 7x minus 3. So we've already got this part of the formula. In the bottom part of it always stays h. So what you got to figure out every time is the f of x plus h. Once we figure that part out, we can plug it all into that formula and then simplify it. Which means our first job is to figure out what the f of x plus h is going to equal. So y'all, what that means is you're going to take this f of x equation they gave us, and guess what I'm going to put in place of that x? We're going to put in there the x plus h. So you take the original function and replace every x with x plus h, and then bring down your minus 3. Now, we're going to do a mellow one tonight just to get you used to this. But y'all come Monday, we might be squaring these and cubing them and doing all kinds of fun stuff, okay? So y'all, how can we simplify this part? I want to get rid of these parentheses. What would you do to get rid of those parentheses?
Would you distribute?
I would definitely distribute. So we would just take that 7 right on through them parentheses. So let's see, that's going to give us what, a 7x plus 7h minus my 3. And y'all guess what? We don't have any like terms. So that is now f of x plus h. So now we're going to put this formula together. Our f of x plus h minus our f of x will all be over that h. All right, let me put that in. 7x plus 7h minus 3. And then this one was a 7x minus 3. So once again, I'm going to get rid of these parentheses on top. This first parenthesis I can drop because there's nothing in front of it. So I got 7x plus 7h minus 3. All right. Now I do have parentheses following subtraction. So we have to distribute our subtraction. So that gives me a minus 7x. But y'all look at that. Negative times a negative makes that a positive 3 all over h. So let me ask you this. Can we do anything to simplify the top of this fraction?
Would it simplify to 7h over h?
Perfect. Y'all notice that? 7x, negative 7x, they sort of cancel. The negative 3 and the positive 3 cancel. So y'all let me tell y'all a little clue about this part of this. Once you get to this stage, the only things that'll be left will have h's in them. All the x's will always cancel. All the numbers will always cancel. The only thing you'll ever have left is the h stuff. So y'all, you got a 7h over h. Can I go further?
Do the h's cancel?
The h's cancel, leaving me with a 7. So, do y'all remember? So this is a fancy slope formula, but y'all remember this, y equals mx plus b stuff? Since this is a straight line, remember the slope is always the number in front of the x. Well, the slope up here was a 7, and what do we get down here? A 7. Now, y'all, it might not be so mellow when I... So y'all want to see one more?
Yes.
Yes.
All right, so let me just turn it up on this one then. Whoops. All right, let me turn this paper over here. So same thing, we're going to construct and simplify the difference quotient. Y'all, this time they're giving us f of x equals x squared plus 3. So remember that all we got f of x, we got the h on the bottom. What we got to find is our f of x plus h. What wasn't bad, it was x squared. So that's going to be x plus h squared plus 3. Now, x plus h squared, remember, we need to do some side work on that. X plus h squared, that's going to be an x plus h times a x plus h. Now, y'all, whatever we get here when we solve this, save that, because it's always going to equal the same when you get an x plus h squared. And then Monday, we'll play with the cubes and all that fun stuff. So here we go. X times x is an x squared. X times h is a hx. I'm just putting them in alphabetical order so it's easy to look at your like terms. H times x is a hx. And then h times h is a h squared. So to go further, I'm just going to add the like terms in the middle. So I get an x squared plus 2 hx's plus my h squared. So save that and use that anytime you get an x plus h squared. So we'll come over here and do x squared plus 2hx plus the h squared. And then at the end, bring down that plus 3. And y'all guess what? Cannot do anything else to that. So let's plug it into our formula. F of x plus h minus f of x all over our h. So y'all, let me just put that in here. And then my f of x was the x squared plus 3. So let me show you what I do. I'm going to drop my parentheses again. Remember, I'm going to distribute that so I get a negative x squared and a negative 3 all over my h. But y'all, I'll tell you, in all reality, you got an x squared here. That's being an x squared subtracted, so they're going to cancel. You got a positive 3 here. You got a 3 being subtracted, so they're going to cancel. Like I said, if it doesn't have an h in it, it's canceling. So let's get to canceling them x squareds and them 3s. So look what's left. 2hx plus h squared over h. What would you do to simplify that one? So let me start y'all out on the first part of this. You got a 2hx over a h.
Would you get rid of the h's?
I would on the first part, so I get a 2x. Now remember, the h also applies to the h squared. So what happens when I got an h squared over a h?
Cancel.
Do what now?
It cancels.
Well, it cancels one of them out.
Oh, we still have one.
Because remember, that's like an h1 sitting there, and you're just subtracting exponents. So 2 h's minus the 1h left me with 1h. And then can't go no further. So since it's an x squared graph, it would be curvy. So this tells me that the slope of this curve depends on the x value and how far the h is in between 2 points. But y'all, we ain't got to know all that. We just got to know how to work this formula, okay? So Monday, we're going to come in and we're going to do probably about 4 or 5 of these type problems. And then I'll probably start us, like I said, reviewing for that next test. All righty, so any questions?
Are you gonna go back over the piecewise?
Am I going to go back over to what?
Piecewise, another example, I'm sorry.
Oh, y'all want another example of the piecewise?
I would, I'm sorry.
So let me go back to at the end where I'm evaluating them. So let me go back into that homework because I can punch up new examples on these. Oh, I didn't put the values in for that while ago. So let me just go back one. And I think, let me look, I think that switched that up. Well, go ahead. Yeah, that switched it. So let's write this down. G of x equals x plus 8 for any x's less than or equal to 2. And y'all, it's going to equal 5 minus x for any x's greater than 2. So let's see, there's 3 they want me to find. G of negative 3, G of 2, and looks like a G of 5. So y'all, let's start out with G of negative 3. All right, so I'm gonna let y'all copy that real quick and then I'll switch to my pad. All right, so here we go. So first of all, I would like to know which of those two equations would I use to evaluate g of -3?
Would it be the top one?
It's going to be the top one because -3 is less than or equal to 2. Good job. So that means on the top one, we're going to put the -3 in for the x. And y'all, -3 plus 8 gives us,
5.
there you go. All right, so next was g of 2. So the question of the day, would you use the top equation or the bottom equation for g of 2?
Would it be the top one?
Because it's equal to 2.
And exactly what I would say, it would be the top one because it's equal to 2. So for that x, we're putting in our 2 plus 8. So that's what, 10. So what's left? G of 5.
The bottom equation.
Because 5 is greater than 2. So you got to see, where does that x value fit in these are sort of like little domain restrictions for each of them. All right, so that's what, a 5 minus 5. And that one's going to give me a 0. So that's the trick on these. Look at these equations. But first, you want to start out, where does my x fit? My x is either going to be less than or equal to that 2 or greater than 2, okay? So did that help you on that?
Yes,
Mm-hmm.
thank you.
Well, y'all did a lot better on that one than we did on that first one a while ago, right? So y'all, this shouldn't be too bad of homework for y'all because y'all were knocking out the increasing and decreasing stuff. And I think y'all are coming around on the piecewise stuff now. Just think of these domains like hours. If I work up to 2 hours, I'm going to use this for my pay. If I work over 2 hours, I'm going to use this one for my pay. So y'all, they're not too bad. It's just, like I said, just playing with them and seeing what you're going to do. So y'all, I don't really have anything else going on tonight. I didn't want to be too long with y'all tonight because we're getting all these storms going to start blowing through on us. So let me stop my share. All righty, so any questions?
No, sir.
So y'all, we're going to knock out some more 5.4 Monday, and then like I said, we're going to start going through our test 2 has 20 questions that exactly match that 20 question study guide. So we'll start going through them and seeing what we can do Monday, okay? So the only thing, so for this week to be on pace, work up through 6.8.
Thank you. Good night.
Thank you.
Y'all be safe out there, and I'll see y'all Monday night, okay?
Okay, thank you.
Bye.
All righty, bye-bye. I'm gonna stop my recording now.